All right, this is one you can kind of just tell when they do this to us that we have 25 meters per second. It starts with a downward speed, so that's initial. It must reduce its speed to 0. That's final. They give us some time. So I bet I'm going to have to solve for the A using equation number 1, which isn't as bad. So let's go to, I always go to what I need first. They need F equals ma. But I've got a lot of forces going on here. I have a weight. So the weight of the object is already given. That's 958 newtons. And that would be directed downward. So its weight is 958 newtons. And I need to know the force of the thrust. So force due to, I don't know, should we call it thrust? Or we could call it force of the rocket. And that equals its mass. I don't know what the mass is. I know what the weight is, but I can solve. If I go W equals mg, m equals weight divided by gravity. My weight is 958 newtons. Gravity is 9.8 meters per second squared. Yeah, that's a weird noise. It's the coffee pot. Just relax. Mass, I believe, is 97.8 kilograms. Oh, I don't plan these things very well. I'm going to start over here. Mass, so mass I'm putting right here as 97.8 kilograms times acceleration. Remember I told you we're going to have to solve for acceleration? There's a lot going on with this question. So I'm going to pull out VF equals VI plus AT. My final velocity is 0 meters per second. Now careful here in your initial, it's a downward speed of 25. So that makes that negative 25 meters per second. That's an easy thing to miss. Plus a t, my t is 8 seconds. So when I subtract or add 25 to both sides, sorry about that, 25 meters per second equals a times t. I'm going to divide that 8 from both sides. And I'm going to get an acceleration of 3.125 meters per second squared. And that's my A here. I just remember I'm running out of room here. This A is coming down there. 3.125. Now I'm going to multiply these two numbers together. And I'm going to get 305.6 newtons. And then I'm going to add 958 to both sides. Newtons. And that's going to be force rocket. So 305.6 plus 958, 305.6 plus 958 gives me about 1263.6 newtons. We could just round that up with sig figs to about 1300 newtons, give or take. And since it's positive, it's got to be upwards. Isn't that part B, I think? They ask what must be the direction of the engine thrust force. And it's got to be upward. Yay. Woo-woo. Woo-woo.